All right, my astronomers. Today we're going to talk about planetary formation. And I'm going to have you listen a little bit here in this video, do a little bit of thinking on your own, and watch another video that is going to be embedded, that is like below this one. So you'll actually have to pause this video, scroll down, play this other YouTube video. Anyway, it'll make sense. So our goal today is to really understand how planets form. We're going to be talking about a certain type of planet called an exoplanet in this unit. But to start out, we want to really understand, how do planets form? So I'm going to have you go ahead and write this on your next blank page on the right-hand side. How do planets form? And I want to know, can we name all of the solar system, all of the planets in our solar system? So take a moment, see if you can. You can jot them down in your notebook. And then that planet that's closest to the sun, it's Mercury. Next, yeah, you're right, it's Venus. Next is a planet you're pretty familiar with. Yeah, home, Earth. So we're the third planet from the sun. Next is Mars. Then there's this thing called the asteroid belt, which is actually mostly empty space with some rocks in it, but we call it the asteroid belt. Then we have Jupiter. Then my favorite planet, obviously the coolest planet, Saturn, Uranus, and Neptune. And maybe you're like, oh, Ms. Guess, what about Pluto? It's next. It's a dwarf planet, so technically not a planet, but don't want to make it feel bad. And so you can use this mnemonic device. My very excellent mother just served us noodles or nachos or nothing if your mother's actually not as excellent. To help you remember the order of the planets in the solar system. And there are some dwarf planets that we aren't going to dig too much into today, but dwarf planets are also objects that are in our solar system. So, good work naming. And we've got these 8 planets in our solar system. They're pretty sweet. And they have some conditions that have to be true for them to count as planets. So some are dwarf planets and they don't count as planets, and we'll get into why. So first off, it has to orbit a star. Everything here orbits stars, even the dwarf planets. We all orbit the sun. So it has to orbit a star. It has to have enough gravity to be mostly a spherical shape. Technically, the planets are all oblate spheroids. They're spheres, but they're a little smushed due to gravity. But it has to be a spherical shape. So, check for all of these guys. And in fact, check for some dwarf planets too. Then, the third condition that is required for something to be a planet is that it has to have an influence on the orbital stability of the other objects in its neighborhood. So essentially that means that it has to have cleared its orbital path of like other random objects and have an influence on that path. And so when we look at some of the dwarf planets like Pluto, for example, it is a dwarf planet because it doesn't actually have a clear orbit. There are other objects in the path of Pluto's orbit, including the planet Neptune. Sometimes Neptune is further away from us than Pluto is, which is a little bit weird. And so these are the conditions that astronomers really think about, but this definition has changed in my lifetime, and it might change over time as we learn more about planets and look at planets outside of our own solar system. So how do planets form? In your notebook, I'm going to ask you to answer 3 questions while watching a video. The video is actually linked below. You have to scroll down on this Schoology page and press play on the other video. Because if I play it in here, it'll have like lower sound quality, lower visual quality, all that jazz. So you're going to watch this other video that's about simulating the solar system's formation. And as you watch this video, really think about what force is driving the formation of planets. How long does it take for planets to form? Oh, see, I started playing. And what's your favorite thing about this video? So you can pause this one and then scroll back up to it after watching this little 4-minute video and answering these 3 questions in your notebook. Awesome. So one thing that you might have had a few questions about as you were watching this video was like, what was up with some of these images? So this video is all about using computer simulations to understand the world. And this is a really common thing in science, especially when we're looking at something that is so long and complicated as planetary formation. We can't see that in a human lifetime at all. And so a real system, like if we're just looking at how objects bounce here on Earth, we could perform experiments and look at our experimental results. But in astronomy, often the real systems, we can't actually change them. We can look at images of them and look at different versions of them to help us improve our understanding. But astronomers often make models, and then they make a computer model of that particular system and actually perform simulations. And you were seeing the results from some simulations on planetary formation, where they use the laws of physics, like the equation for the force of gravity and the equations of motion, which are all actually posted up in our room right now for my IB physics class. And they make a simulation of what would happen, how would masses interact, and construct theories using those simulations. They use the simulations, look at the results, and see how they compare to what we can see in the world around us. So this is just a cool way that we use computer modeling to really help us understand things that are beyond human timescales or beyond the visibility of the human perception. So as you learned in this video, stars form, and as we learned last unit, stars form in a nebula in a collapsing cloud of gas and dust. And gravity is actually causing it to collapse, causing the gas and dust to collect together. In a nebula, we see the image. It looks pretty static, but actually all of the gas and dust in a nebula are moving around. They're doing it in a way that we can't see because human lifetimes are pretty short, but they're moving and changing. And so as gravity pulls gas and dust together, this cloud is actually spinning. And it's rotating, and it forms this thing called a protoplanetary disk. Again, we learned about this with protostars. So the protostar is at the center, not yet going through nuclear fusion, but a lot of gravity, a lot of heat building up in the middle. And as this happens, this disk is spinning. It's collapsing. The gravity is pulling it together. And the fact that it's moving, the conservation of angular momentum, the total momentum of the system, actually causes it to become flatter and flatter and flatter, kind of like a person spinning a pizza, and it flattens out, and the particles closer are rotating faster, the particles further away are rotating a little bit slower. And so this protoplanetary disk develops areas of accretion in its accretion disk, where mass is sort of clumping together, and we start getting planetesimals. And as you heard in the video, the planetesimals start out pretty darn small, just a few centimeters. Little groups of dust that have sort of smushed together into rocks. And these planetesimals are pebble-sized, they're pretty small, and they start to actually collapse together. One planetesimal runs into another, and if they run into each other at the right rate, they start to collapse together gravitationally. Sometimes they spread out because of their running into each other, but gradually over time, these planetesimals build up larger and larger, and we get protoplanets, just like we had a protostar. So those are not yet planets. Throughout a solar system as it's forming, the area closest to the star is the hottest area. That's where the dust and gas have compressed the most. And in this section, we actually get mostly, the planets are mostly made of metals like iron. So those are heavy rocks and dust and gases that collect there. And in fact, a lot of the gases in this middle part are kind of blown away from the star's energy as it starts to heat up, starts to go through nuclear fusion. The second closest area, so this region out here, we get more rocky materials. So that's sort of where Earth formed. We get a lot of rocky materials, still some metals like iron, but actually not a lot of water, kind of weird, and very little other gas and dust, because the star actually kind of pushes that away and burns that up until this area where there's this thing called the frost line. the farthest away area where planetesimals are forming. It's cooler out here. And we get ice and complex ice. Complex ice means it's ice not made of water. It's like methane or carbon dioxide. And that's what the planet Jupiter is. So we get these different types of planets that form depending on where they are relative to their star. So we categorize planets based on these different types of formation. We have terrestrial planets, which are mostly solid materials, so rock and metal. They have metal cores, rocky exteriors, and they tend to be closer to their stars. We have gas giants, which are mostly made of hydrogen and helium. So they're pretty light, but they're quite large, very massive. They've really sucked up the remaining hydrogen and helium in a solar system as that star has formed. And then the last chunk, which are called ice giants. And they actually are in the outer edges of a solar system where they have a lot of ices, a lot of things that are made of water ice, but also ice methane, ice CO2. So lots of frozen molecules in these outer gas giants that we call ice giants. And so these different flavors of planets are part of our solar system. And I'd like you to spend a little bit of time right now really thinking about how would you describe how planets formed to a younger sibling. You're going to do this process journal, maybe page 25. I think 3A might actually be on page 35. I don't quite remember. That's why it's up to you what page it's on. But you want to do either two pretty quick things, like a summary and a little concept map, or maybe writing an Instagram post, or a couple of test questions. Or if you do one really big, nice, detailed thing, maybe you make a storyboard, or a short story, or a drawing where there's a summary for each kind of section. So take a little bit of time, make a summary of how do planets form that would make sense to a younger sibling, or maybe your grandma or your cousins, someone who's not very familiar with topics in astronomy. And then go ahead and turn that in on assignment 3.1. Thanks so much, astronomers. Hope you've had a great day.